Hi friends, today we'll learn about AWS Athena. So we'll be querying S3 data from Athena, and for creating Athena DB and table definitions, we'll be using AWS Glue crawler. So if you don't know anything about Athena or Glue, do not worry and just stay with me. You'll be able to set up Athena DB and tables at the end of this video. First, I'll give you a brief introduction about uh, AWS Athena, and then we'll dive into the hands-on lab. So let's get started. So Athena is a serverless interactive query system. So it means that you don't have to spin up servers and do not need to worry about scaling up and down. In case load increases or you fire some parallel queries, you just need to submit your query and let it run. So it works on data stored in S3, and we know that S3 is quite popular nowadays for storing big data because of its high availability and less cost. So you can directly query your data in S3 from Athena. Also, it uses ANSI SQL for firing the queries, so that you don't have to learn a new querying framework. If you know about MySQL or Oracle, then I think you are good to go with this. Apart from that, it supports variety of file formats against which you can fire the queries. So there are CSV formats, JSON formats, Avro, ORC, and Parquet. The last two formats, ORC and Parquet, these are columnar storage, and they are quite famous in big data world because of their storage efficiency, and it is recommended to use these two formats. So for Athena, pricing of Athena is per query basis, and how much data your query scans. So let's move on. So you can quickly query unstructured, semi-structured, and structured data. You just need to create table point S3 folder where the data is located, and that is it. So it uses Presto SQL at the backend, and Presto is quite famous query data engine in big data world. So coming to the access part, there are quite different ways to access Amazon Athena. You can use console, API, CLI, or JDBC connection. One good thing about Athena is it integrates well with the other AWS services like Glue and QuickSight. So AWS Glue is a ETL tool and QuickSight is a BI tool. So that provides insights and visualizations and interactive dashboards. You can create pie charts, bar graphs with the Amazon Athena results. Let's move. So let's talk about why Athena got popular. So Athena has become very popular in querying big data, which is stored in S3 and used by data analysts for the same. When we talk about big data, we are dealing with huge amount of data, which is not easy to read and easy to analyze. For the very same reason, we set up Hadoop clusters, or we use big data platforms like EMR, or we use data warehousing solutions like AWS own Redshift or Informatica or Teradata. But with Athena, you don't need to spin up servers or set up Hadoop clusters. You can just directly query the data stored in S3. Next is Athena use cases. So the first, you can analyze any type of AWS logs such as CloudTrail, CloudFront, or VPC or ELB logs. So you can point the existing logs of AWS and query them. Another is you can integrate JDBC, uh, Athena JDBC, and you can integrate with other visualization tools from your local workspace. Then you can do ad hoc logs analysis, such as analyzing your Tomcat logs or ELK stack logs. Basically, you can segregate the logs in terms of exceptions or the user behavior have. So this diagram, is a classic use case wherein Athena is used. So what happens is, you have different sources which puts data into S3, and the sources can be Amazon Kinesis Stream or Kafka or any other process working on your local or production environment which is pushing data to S3. Then data is uh, crawled by the AWS group crawlers. So they run periodically or they can run on ad hoc basis and automatically populate the catalog. And that catalog is basically used by both the systems. It can be used by the Redshift Spectrum, or it can be used by Amazon Athena. So from Athena, data can be sent to Amazon QuickSight, where it you can use visualization tools and show it to your customers, or show it to your data analyst, which performs crucial decision making. We'll move on to Athena cost model. So it is very important, when we are dealing with AWS, we should know about how much AWS would be costing us. So for Athena, we'll be only paying for the queries and the data scanned by the query. So it is $5 per TB of data scanned, and you are charged for the number of bytes scanned. So with minimum amount of 10 MB per query. So there are no charges for DDL. So you can, when you create tables, databases, views, or alter them or load partitions, then you're not charged for that. And you are also not charged for the failed query. So this is a very important thing to know. Another thing is there are charges for cancelled queries. For example, you fired a query, which needs to, get results from a folder, S3 folder, which has TBs of data. So after 1 minute, you got to know that, your query would scan the complete data set. So rather you should provide a where clause, in the query. Then if you cancel the query, then you would be charged for the data it has already scanned. So there are variety of ways, you can save the cost. The first uh, way is to use columnar formats, which is Parquet and ORC, which we already covered that, these are storage efficient formats, and you'll be charged less in S3. And obviously, if the memory footprint is less for Parquet and ORC, so less data would be scanned. Then using partitions. So partition is something like, similar to your where clause. If you provide partition in your data, then you could use where clause so that that particular folder would be scanned. Another thing is compression. You should use compression in S3, and with compression there would be less data in S3, and less data would be scanned again. Another point is more related to performance optimization. So you should decide on the file size which you should store in S3. I mean, the file size should not be very less. Optimal size of file, let's say, 10 MB to 40 MB, so that, Athena doesn't have to combine the files at runtime. Let's talk about how to create tables in Athena. So table creation is very simple in Athena. You can use TTL commands, you can use AWS Glue crawler or JDBC driver, or table create table wizard. So this is done in Amazon AWS Management Console. Apart from that, there are views also wherein you want to combine results from multiple tables. So a simple create table command would be like this, create external table, and the table name. Then you can provide the column names and their data types. Then you should provide the serialization and deserialization format. Let's say it is regex day, and then you provide the location where the data would be present, so that this table scans and give you results from that data only, that folder only. So let's move on. So one important concept in Athena query is whenever you fire a query, then that query results is stored in S3. So in future, if you want to access only that particular data set, you can directly go and and download that data set. You don't have to again run the query that scans again that same data, and you would be charged for that. Also, for storing that data, the result data, you need to specify the output folder in S3. There are some limitations in Athena queries also. For example, stored procedures are not supported, and certain DDL operations are also not supported. Another feature which is quite recently introduced is Athena federated queries. So for now, when you query the data, you provide S3 folder. So with federated queries, you can combine the results from multiple data sources. For example, DynamoDB or another AWS data storage service. So these are some of the questions that could appear in AWS certification examinations if you are preparing for that. So you can pause this video and check these questions, and do mention the answers in the comments below. So in future uploads, I'll try to cover these topics. So let's move on to Athena lab now. So I am into my AWS console. So what you need to do is you need to search for Amazon Athena here, and you land on this page. So you just click on get started. So the first step would be to load the sample data into S3 bucket. Then I've already done that. I created one S3 bucket named AWS Athena lab, and then created one folder water data, and uploaded one water data.csv. So this data I downloaded it from data.gov.in. So this is a government of India website wherein you can find public data. So so let's discuss the next steps. So once you're done with this CSV upload, then we can go on to Glue. So Glue is a ETL service, and we'll use Glue crawlers. So in this video, we'll be covering Glue crawlers, and if you want to create tables based on create table wizard or any other format, I mean that's very easy. I'll show you at the end of this video. So let's get started with the Glue. So this is the home screen of Glue. Here you could find ELB logs if you have already used ELB. Uh, you'll see the data catalog at the left hand side. We'll be dealing with this section only. There are databases, tables, connections, crawlers. So let's move to crawlers now. So you'll find that you don't have any crawlers yet. So we can click on add crawler for now. Here you need to provide a crawler name, and let's name it as water data crawler. Okay, here you can give a tag description, whatever you want to give. So I think you might be aware that tags help us to categorize the various resources. Now I'm keeping it blank for now. I'll click on next. So here you need to specify the source type. So my source would be the data stores. So here I have three options now. So I can choose, JDBC or DynamoDB or S3. So, but I'll choose S3 because my data is in S3. And here you need to provide the bucket path where exactly your data is. So you can click on this icon and it will show you all the buckets that you have. So in my bucket, I need to crawl data for this folder only, water data. So I can select water data here and select it. So this exclude pattern is basically for excluding any subfolder inside the water data that you don't want to scan and don't want crawlers to create table definitions. So you can provide, if there are any logs, you can provide like logs slash star star, then it will skip all the folder or subfolders inside the logs. Now you can click next. So do you want to add another data store? So I'll select no for now and click on next. So the next is choosing IAM role. So this point is very important. You need to have S3 read permissions to read the data. So here you will provide S3 get object access to Athena and Glue. And for Glue it is necessary because crawler has to run and fetch the metadata information after reading the file. And for Athena, it is obvious that we should have access to the folder against which we'll be running queries. So if you have already IAM role created, then you can choose the existing IAM role. It will give you give you in the drop down option. But I don't have any, so I'll create an IAM role here. So let's say that my role name is for this particular water data. So I'll click next. So here this option gives us the frequency of our crawler. So there are numerous options like run on demand, hourly, daily. So you can choose the frequency based on hourly, daily. If you anticipate that new data could be added to this folder, that could change the schema. For now I'll choose run on demand, and I'll click next. So here we configure the crawler's output. So we must choose one DB where table definition would be added. So if you don't have DB for now, you can click on add database, and you can provide any database name. So let's say I give it my database name for now, and I click on create. So it will create a new database, so in Athena. And if you want to prefix any add any prefix to the table, let's say that if I'm dealing with all the water data and all my table should be prefixed with water hyphen, then you can add the prefix. I'm skipping it for now. And the next two sections are actually, good to know. So if you want to group compatible schema types into a single table, so this is recommended, and you can click on create a single schema for each S3 path. So if this is recommended if you are playing with large data set and you expect that files could have same data format. If you choose next is configuring next configuration options are if you are dealing with the frequency of the crawler. So if you choose frequency as daily or hourly and expect data changes in the crawler, then what exactly do you want to do with that schema changes? You can select update table definitions or add new columns only, or ignore the changes at all. So these are options, and based on your use case you can select these two options. Next is for reviewing purpose, you can review what exactly have you given, and you can click on finish. So now crawler is created. You'll get this option as it is created and to run on demand. So if you want to run it now, just click on it. I'm clicking on it right now. So it will try to it will attempt to run the crawler, and you will see that status would be changed from ready to starting here. So let's refresh for now, and let's say so now it is starting. And when a crawler runs, it also creates some logs in the CloudWatch also. So meanwhile, we can go to CloudWatch to see what exactly is going on. Anyway, you'll get the link here also in the logs, and whatever the tables are created, you'll be getting the results here. So let's go to CloudWatch now. In CloudWatch, go to the log groups. So all the AWS related uh, logs are created here. So here you can see that AWS Glue and crawlers. So when you click on that, you will see the water data crawler. You must be aware that when we started with this crawler, we had given the name as water data crawler. So when you click on this, and you can mark it as text, you'll see that running start crawler for water data crawler. So right now it is still running at the back end, and we don't have any logs, so let's wait for it. So now I just refreshed, and I could see that classification complete, writing result to database, my database, and it created one table as water data. And the table name would be same as the folder which you select for S3. So now I'll go to the crawler and I'll refresh. So you will see that it is in stopping status, and one table is created. So you can move to this database section and table. You can click on tables. You'll see that just refresh it, and you'll see water data also. So you can open it, you can check its properties, okay, with whatever are the columns name, and then you can edit the table. You can edit schema also. So why edit schema is here? For example, let's say that the data in your folder is the scanned by Glue crawler is not exactly the same, the data type. So let's say that data is in double format, or let's say data is in integer, but when Glue scanned it, it made it as string. So you can just go to edit schema, and you can click on data type in this column, and you can just select it, and then select the database and then update this. So when you click on update, you again have to click on save to save the changes. So these changes would reflect automatically in the Athena. Okay, so now let's move on to Athena. So click on get started. So when you open this, you'll see a new database there with the name of my database. So this is my database, and you could see here that we have a water data table. When you click on this, it will show you all the columns of this table and with their respective data types. So now you want to run a query, you can just click on this and click on preview table, or you can write yourself a select query. So I'll write preview table. Oh my gosh, so we got an error. So it says that your query has following errors, no output location provided. So now this is what I was talking about in our PPT. So what we need to do is we need to provide output location in queries so that it stores the data. You can see that I mentioned one point here: query results and metadata information is stored. So you need to specify output folder for storing the output. So what you can do for now is you can just click on this link here, set up a query result location in Amazon S3, and you can give the query result location. So what I can do is I can in this uh, bucket I'll create one folder. So I'll write it as Athena output. Okay, I'll create this folder. So this is Athena output. Now I'll go to Athena, and I'll give the complete path of Athena output. So you can copy path from here, Athena lab, and then Athena output. Just update this in Athena lab, Athena output. That's it. That is it. So you can select encrypt query results if you want to encrypt the results for security purposes. And you can click autocomplete, to show you some options when you are typing the query, or otherwise you can enter command control and space. So let's keep it as it is here and click on save. Now again run the same query. So you can see that it is running, and so yeah, this is it. We got our results. So this query is limiting the data to 10. So you can see that runtime of this query is 1.51 seconds, and data scanned is 72.41 KB. So this is it. You'll get to know data scanned for each query whenever you run that. And you can play with this query. You can remove the limit part. You can provide where clause also, and you just play with this. Okay, so this is the data that you have. Now let's discuss the Athena UI part. So you can save some of the queries in your Athena which you want to run frequently in the saved queries. So when you go to saved queries, it shows you the saved query for the this as a sample queries. So let's say that in query editor, if you want to save the query, you can just save this, save as my query, and it will be saved at top 10 records. Just give it anything here, and it will be saved in the saved queries. So this is my query, you can see, and you can just select it, and you can delete it, or you can copy it and run it again. So in the history section, you will be getting all the queries that you fired in Athena. So we now, for the time being, fired only two queries. The first is with limit 10, and another is without any limit. Yeah, so it gives you again the same data that it took this much time and this much results, and you can download the results. So you can imagine that this download result is possible because we are storing the output of Athena. Then yeah, this is it from the Athena Glue and S3. So if you want to create tables without using Glue, that is very simple. So when you click on water data, so these three dots, when you click on this, you will see the generate table DDL option. So when you click on this, you will see the generate table DDL. So you can copy this entire DDL command, and you can change the path here. You can change the path here, table properties or location, survey, and column names, and you can just click on run query. And yeah, apart from that, you can see the properties here directly through here, then delete the table. And for creating tables without using Glue, again you can use this option, create table link here. So this is a table creation wizard from Athena. So when you click on Glue, we already explored. If you click on S3 bucket data, then it will give us step-by-step process wherein you choose a database. Let's say that my database, then you choose a table name, my table, then you give the path. Let's say that I give the path. It will not take it actually. and there's no folder, there's no valid folder here. So let's say that I create a path here. Yeah, and then if I click on next, it asks for the data format. You can choose any format, provide the regex. Let's say I give it CSV for now. You can click on next, then you need to add all the columns here. So you can add bulk columns here in the form of text, and or you can give manually. So let's say that first is serial number with int, then you click on next. Then if you want to configure the partitions, then you can do that. You can add the partition based on the folder structure. Then you click on create table. So yeah, for now we don't have any data. So so this is it. This is it from the Athena part. And if you have any question, you can ask me in the comment section, and I'll try to um, answer your queries, and I'll come up with the new topics that I already uh, um, told you in the future videos. Yeah, thank you guys.